Good morning. In the last session, we have discussed the application of refrigeration in food processing and preservation industries. Today, we will see the application of refrigeration in chemical and process industry and some special application. Firstly, the application in chemical and process industry. The industries like petroleum, petrochemical plant, paper pulp industry require very large cooling capacities. The requirement of each industry, process-wise and equipment-wise, is different. Hence, the refrigeration system has to be customized and optimized for individual application. The main application involves following categories. Firstly, separation of gases. In petrochemical plant, the temperature as low as minus 150 degrees centigrade with a refrigeration capacity as high as 10,000 ton are used for separation of gases by fractional distillation. Some gases condense readily at lower temperature from the mixture of hydrocarbon. Propane is used as a refrigerant in many of these plants. The second category is condensation of gases. Some gases that are produced synthetically are condensed to liquid state by cooling so that these can be easily stored and transported in liquid state. For example, in synthetic ammonia plant, ammonia is condensed at minus 10 to 10 degrees centigrade before filling in cylinder for storage and shipment. This low temperature requires refrigeration. Then dehumidification of air. Low humidity is required in many pharmaceutical industry. It is also required for air liquefaction plant. This is also required to prevent static electricity and prevent short circuit in places where high voltage are used. The air is cooled down below its due temperature so that some water vapor condenses out and air gets dehumidified. Another application is solidification of solute. One of the process of separation of a substance or pollutant or impurity from a liquid mixture is by its solidification at low temperature. Lubricating oil is de-waxed in petroleum industry by cooling it below minus 25. The wax solidifies at minus 25 and gets separated. Fifth application, storage as liquid at low pressure. Liquid occupies less space than gases. Most of the refrigerant are stored at high pressure. This pressure is usually the saturation pressure at atmospheric temperature. For some gases, saturation pressure at room temperature is very high. Hence, these are stored at relatively low pressure and temperature. For example, the natural gas is stored at 0.7 gauge pressure and minus 130 degrees centigrade. Heat gain by cylinder valve leads to boiling of some gas which is compressed, cooled and expanded back to 0.7. Another application is removal of heat of rejection. In many chemical process, efficiency is better if it occurs below room temperature. This requires refrigeration. If these reactions are exothermic in nature, then more refrigeration capacities are required. Production of viscose, rayon, cellular acetate, and synthetic rubber are some of the examples. Fermentation is also one of the examples. Another application is cooling for preservation. Many compounds decompose at room temperature or these evaporate at very fast rate. Certain category of drug, explosive, and natural rubber can be stored for long period at lower temperature. Last one, recovery of solvent. In many chemical processes, solvents are used, which usually evaporate after processing. These can be recovered by condensation at low temperature by refrigeration system. One of the example is acetone in film manufacture. Another is carbon tetrachloride in textile production. Then we have another special category. In this category, we consider applications other than chemical uses. These are in manufacturing process, application in medicine, construction unit, etc. The first one is cold treatment of metal. The dimensions of precision parts and gauge block can be stabilized by soaking the product at temperature around -90. The hardness and wear resistance of carbide steel can be increased by this process. Keeping the cutting tool at -100 degrees centigrade for 15 minutes can also increase the life of cutting tool. In deep drying process, the ductility of metal increases at low temperature. Mercury pattern frozen by refrigeration can be used for precision casting. Medical, blood plasma and antibiotics are manufactured by freeze drying process where water is made to sublime at low pressure and temperature. This does not affect the tissue of blood. Centrifuges refrigerated at -10 are used in manufacture of drug. Localized refrigeration by liquid nitrogen can be used as anesthesia also. Ice skating. Due to advent of artificial refrigeration, sports like ice hockey and skating do not have to depend upon freezing weather. These can be played in indoor stadium where water is frozen into ice on the floor. The refrigerant or brine carrying the pipes are embedded below the floor, which cools and freezes the water to ice over the floor. Construction. The setting of concrete is an exothermic process. If the heat of setting is not removed, the concrete will expand and produce the cracking structure. The concrete may be cooled by cooling sand, gravel, and water before mixing them, or by passing chilled water through the pipe embedded in concrete. Another application is to freeze the wet soil by refrigeration to facilitate its excavation. Then, desalination of water. In some countries, the availability of fresh water is very less, and seawater is desalined to obtain the fresh water. Solar energy is used in some cases of desalination. An alternative is to freeze the seawater. The ice thus formed will be relatively free of salt. The ice can be separated and we can obtain fresh water from it. Ice manufacturing. This is the classical application of refrigeration. Ice was manufactured in plants by dipping water containers in chilled solution, and it is used to take about 36 hours to freeze all water in cans into ice. The ice thus formed is stored in ice warehouse. Now that small freezers and ice makers are available, hotel and restaurant make their own ice in a hygienic manner. Household refrigerator also have the facility to make ice in small quantities. The use of ice warehouse is now minimizing because of these reasons. The coastal areas still have ice plant where it is used for transportation of iced fish. The refrigeration systems are also required in remote places for a wide variety of applications such as storage of milk, vegetable, fruit, and also for storage of vaccine in health center. One typical problem with many of the places is continuous availability of power. Since space is not a constraint, most of the places in tropical countries are blessed with alternate energy source such as solar energy, biomass, etc. It is preferable to use these clean and renewable energy source in these areas. Thermal energy driven system can also be used. Vapor compression system running on photovoltaic cell or solar energy have also been developed and can be utilized in such places where the problem of electricity is there. So these were the applications of refrigeration systems. In the next session, we will be discussing in detail how a refrigeration system works and what is its basic cycle of operation. Thank you.